Okay, so good afternoon, everyone. I'm adding this additional recording, no, so that um, you can have an idea on how to do the other examples stated in this module or given in this module. Um, we ended with case 6, no? Parang nagbigay ako ng additional case wherein nakuha ko lang to sa yung previous PowerPoints namin, no? But I've also labeled yung mga different na exercises na ginawa na natin. So we have exercise 1, nagawa natin yun, which is siya yung this one, no? No, sorry. Yes, yes. This is exercise 1. We also did, which is case 1. Exercise 2 was case 3. Kalagay na dyan. And exercise 3. Then we added an additional case 6 using this example sa PowerPoint. Okay? So, balak ko ngayon para hindi ko na ililink yung other videos ko, no, para mas madali yung mahanap. Gawin na lang natin is tapusin na lang natin lahat ng mga examples na nandito sa module na to. Okay? So we ended with uh, exercise 3. So tuloy natin siya hanggang exercise should be at exercise 4 na, no, or example 4. Okay? So this is example 4. Meron daw tayong um, may two cases tayo wherein meron siyang androgen injection. No? So the levels of androgen daw at time of capture and 30 minutes later measured in nanograms per milliliters for 15 deers are given below. If the population of androgen levels at the time of injection and 30 minutes later are normally distributed, let us test at 0.05 level of significance whether androgen concentrations are altered after 30 minutes. So again, ito na-discuss ko konti sa no, yung sa live synchronous session natin kanina. Sabi natin whenever you have sort of like before and after na type of arrangement or type of data set, then that is most likely a paired observation setup, no. So this is exactly like that, no. So meron tayong before and after. So parang ang before natin is at the time of injection. And let me zoom in a little bit. So ang before natin is at the time of injection, tapos ang after naman natin is 30 minutes after the injection. Okay? So you'll know na ano siya, paired observation. And again, I've discussed this earlier pero reiterate ko na lang din. You know that paired observation siya if a specific sample, in this case yung specific deer, no, experiences both parang both conditions, no. So itong deer 1 naka-experience siya ng at the time of injection na condition at yung 30 minutes after injection na condition. So, these two data sets na nakuha natin, ito 2.76 and 7.02, come from the same deer. So, ganun natin nalalaman na paired observation siya. Kasi it's one sample and it has two pairs or it has one pair of observations, which is different from yung ginawa natin na ganito, no? Yung modified and unmodified, kasi hindi necessary na itong sample 1 na to was modified and kumuha din tayo ng the same sample 1 and kinuha natin yung original na unmodified sample 1, no. Totally different itong 10 samples na to sa 10 samples na to. So in that case, comparison of two means to, hindi siya paired observations. Okay, so let's add to new sheet. Let's name this E4. And since paired observations to, then this is case 7, no? Paired observation is case 7. And unfortunately, itong sa no, example natin, hindi siya let me just maximize this. Hindi siya naka table form. So I'll have to copy this entirely again, no? So bear with me dito class, no? 7, 8, and I can drag this down actually, no? Hanggang 15. So, yan yung kagandahan ni Excel, no? If you have a series of numbers, pwede niya actually i-autofill, no? So, that could be a time-saving uh, na feature, no? Okay? So, let's do at time of, of injection. So, siguro, once you finish this video, pwede siguro i-skip nyo na lang tong parts na to, no? Para skip nyo na lang siya para mas mabilis yung matapos yung video, no? So, I'll just be doing 2.76, 5.18, 2.68. I could edit this video, no? Tapos i-speed up ko. Pero, uh, it requires that I do Premiere Pro na editing, no? Which takes a bit of time kasi hindi naman ako super pro sa paggamit, no? So, kayo na lang bahala, no? Or pwede naman sa YouTube ko lang i-edit to. So most likely pag nakita nyo to sa YouTube, baka naka-trim na to, no? Na skinip ko na yung part na, yung boring part na nagta-type ako dito. Okay, with a bit of magic, no? Hopefully, na-skip nyo yung part na I'm tediously typing this, no? So, ito na yung data natin. And actually, di natin kailangan tong DI, no? This is just the difference between the two before and after na conditions, no? So, parang formula ito is itong 30 minutes minus yung at the time of injection. We need this kung maglo-long method tayo, pero what I'll be showing you now is a short method lang, no? So, pwede natin delete lang actually ito, no? And I can probably delete this as well. Okay? So, siguro ang best or ang easiest way to do this is you use the data analysis toolpack again, no? So, if you do data analysis toolpack, it's again, look at the top ribbon, punta kayo sa data, tapos dito sa data, hanapin nyo yung data analysis. Okay? Hindi ko alam, parang na-crop ata, no? So, let me extend konti. Yan. So, doon sa data ribbon, hanapin natin data analysis toolpack. Buksan natin siya. Then, we find the t-test, no? So, paired observations are still t-tests. So, let's look. T-test, eto, nandito siya. T-test paired to sample for means. So, this is paired observation. So, click OK. First variable range 1, we can include the labels, no? Tapos i-tick na lang natin yung labels na checkbox. So include natin yung labels dyan. Include natin dito. So that's variable number 2. Yan. So this is the first one and this is the second one. Hindi nagmamatter, no, kung pagbaliktad nyo. Basta just note that this is x1, this is x2. Okay? Or mu1, mu2. Okay, so you don't have any hypothesized difference, no? Kasi based dun sa problem, and we can go back to the problem, no? Based sa problem naman, wala namang sinabi na we are not asserting na mayroong difference between the two of them, no? So it's okay na i-ano natin to. I-set natin to 0 and i-click natin yung labels kasi dun sa yung data range na sinelect natin, sinama natin tong label. So, check natin siya. Alpha is 0.05. Tama nga ba? 0.05 nga ba yun? Let us check. Sabi dito, at level 0.05. Ito. So, we'll use 0.05. Okay? So, 0.05, output range natin, lagay lang natin somewhere sa blank space, no? So, I can place it somewhere here siguro. Then, we press OK. Tapos, nandito na yung data natin. So, t-stat here, this is our t-crit. Itong value na to, t-crit. This p here is the p-value if you use a one-tail test. Tapos, ito naman, p-value if it's a two-tail test. And let's look at the problem, no? Kung meron bang sinabi na kung two-tail to or not. So, ang sabi naman dito is test whether the concentrations are altered after 30 minutes. Okay? So, hindi niya sinabi or hindi ina-assert, no, or hina-hypothesize na kung mas mataas ba ang 30 minutes after or mas mababa siya. So, wala siyang, kumbaga, any directionality. I use the term directionality, no, para mas ma-imagine nyo. So, in this sense, it's a two-tailed test, no? So, pwede natin ilagay. So, if we were to do the steps now, so H1 and H0 and H1 muna tayo. So, our H1 would be, si mu1 is equal to mu2. And try ko nga, baka nakasave pa yung mu ko dito. Nakasave pa siya. So, mu1 and mu2. By the way, if you're curious on how I did that, if you press, I don't know if you need to activate this in Windows. No, pero pwede actually Windows key plus V, it will give you a history of your clipboard. No? But I think you need to activate this. So maganda to kasi nandyan yung history ng kinopy mong mga text. No? Anyways, ano na yun, parang ano na yun, unrelated tip, kumbaga. But you can use it. No? Okay? So let me zoom in a bit. So, ito, mu1 is equal to mu2. Tapos, yung h naught natin is that mu1 is not equal to mu2. Okay? Now, let's state it as a phrase or as a sentence. Parang sinasabi natin dito na hmm, levels, the androgen concentration is not altered after 30 minutes. After 30 minutes, parang ganyan lang, no? As simple as that. Tapos, dito naman, the androgen concentration is altered after 30 minutes. So again, parating yung H1 is the logical complement of H0, no? Okay? So, ito, status quo, ito yung ina-assert natin. So, we have H1 and H0, and we set an alpha value. For the problem, we set it as 0.05. Now, we go to this is a t test, no? So t value yung ano natin, test statistic. So we go t crit is equal to, this is the t crit here. T crit is this is a two-tailed test. So ito yung gagamitin natin, yung t critical two-tailed. Oh, that's our t crit. T calc natin will be equal siya sa itong t stat, which is this one right here. So it's negative siya kasi nasa sa negative tail siya, pero again when we're concluding, we always get the absolute value, no? So pwede naman. But if you don't want to deal with the negatives, pwede naman i-negate na natin as early as now, no? Para yung t-calc natin naka-positive na siya. Okay? So pwedeng ganun na lang gawin natin. Okay? So if we have this, we can also get the p-value, no? And the p-value is also given right here. P-value is, this is a two-tailed test, therefore itong 0.058. So again, we can do this. Ito, madali lang, no? Kasi ginamit natin yung, anong tawag dito, data analysis tool pack. Pero pwede rin gamitin natin is yung manual method, no? And the manual method, and if I go back to the module, ito yung computation sa manual. No? You get the difference, summation of the difference, kaya may difference table dito. Tapos, you get the standard deviation of the difference. No? Tapos, from there, pwede mo na makompute itong t-statistic na to. Pero, will not be doing that anymore. No? You can just try to do it on your own. If you opt to use the manual method or the long method, pwede itong short method na lang yung gamitin natin. Okay? So, p-value, there's also another way of solving p-value. No? Pwede actually ang gamitin natin is t.test. So, if you do t.test, parang ganyan, t.test, tapos you select array 1, which is, this is array 1 natin. So, this is our mu1. As array 2 is this one. So, we have 1, 2, 3, 4 arguments dito para sa specific formula na to, no? So, the third argument is whether it's a one-tailed or a two-tailed. And we're doing two-tailed, so 2. Tapos, ito yung type of t-test na gagamitin natin. So, we're doing paired observation, no? So, paired, kaya 1 yung itatype natin dito. So, if we type that, t-test, we should get the same value here, no? Okay? So, notice if you do p-values, you don't actually, kumbaga, pwede mo skip na tong t-crit and t-calc part, no? Kasi when you do p-value, automatic naman na you just compare this to the alpha value. So, actually, pwede mo skip to if you do p-value analysis. Okay? Pero let's just, add this for completeness. So, we can do since t-calc, and just to be complete, lagyan natin absolute value na lang, parang ganyan. since tcalc is greater than tcrit, then we, oh no, sorry, it's not greater pala. It's less than tcrit. Then uh, we fail to reject H naught. Pero again, parang binanggit ko sa synchronous session, no? Hindi naman tayo parang statistical Nazi dito. So, pwedeng kahit hindi natin sabihin fail to reject, sabihin na lang natin diretso accept H naught to. Ayan, okay lang sa atin yun. So, kumbaga, we know what we mean dito pagka when we say accept H naught. Okay? Tapos next is since pwede rin p-value, no? P-value or just p. P is greater than alpha. Then we arrive at the same conclusion, no? Then accept H naught. Okay? Therefore, ang conclusion natin is, therefore, we make an engineering conclusion that the we accept H naught, so therefore the androgen is not altered after 30 minutes. Okay, and let's go back to the, I don't know, and if we get the same results, 2.06, let me just 2.06, ito naka ano na, no, round off yung p-value na 0.06. Then you have the same 2.06. Tapos, so ang conclusion niya is that the sample showed that there is some evidence that there is a difference. Imputed p-value. Wait lang. Oh. May konting mali dito sa ano, no? Okay. Ito yung sinasabi ko kanina, no, na parang yung p-value approach wherein sinasabi natin na kumbaga mas flexible si p-value approach, no, kasi hindi siya hard na, no. So you'll notice na ito 0.05, very close to the alpha value siya, no, itong 0.057 or 0.06. Kaya parang kaya ang conclusion niya is there is some evidence that there is a difference in the mean circulation of the androgen levels based on this low p value, no. So it's not enough if you, kasi kung finix natin yung alpha natin at 0.05, then definitely hindi siya enough para pumasok sa critical region, no. Pero again, kaya most scientists and most newer researchers ngayon gusto yun ng p-value approach kasi hindi siya hard rule, no. Pwedeng kahit um, based on statistics or based on the alpha levels na sinet, dapat nag-conclude ka otherwise. Pero based on parang ano ba, based on um, your understanding of the p-value, then we can say na kahit hindi siya we cannot make the conclusion at 95% confidence level, we can make it at a different confidence level, no. So kumbaga kaya ang sinasabi dito there is still some evidence, no. So that could be one of, and again ito yung I alluded to this earlier dun sa synchronous session, no, na kaya gusto ng mga scientists itong or new researchers itong p-value because it's more flexible, no. So parang we can make the interpretation here na if we were to choose an alpha value of 0.0579, then significant dapat yung result natin. Pero from the start we chose 0.05. So yun for and again the statistical purist will be ano, no, parang sobrang oppose sila dito, no, na parang bakit ginagawa yung flexible itong statistical test na to. Okay, so it depends on you guys kung paano nyo you can read more about it, no, and try to decide for yourself kung where you fall within this parang we can call it as sort of gray area, no. Ako I understand both sides, no, na parang dapat hard limit talaga siya, pero at the same time parang I also understand the value of ano, no, of the interpretation that the p-value introduces, no? So uh, I'm undecided ako dito, no? Right? So let's just say dito we set it as hard na ano, no, na limit or consideration such that etong kung ano yung since 0.05 na yung sinat natin from the start, then we must abide by it, no? So kung ganon, and therefore the androgen concentration, we accept the H na to, na androgen concentration is not altered after 30 minutes. Okay? So next natin is let's do example number 5 naman. So let's do dito E5, and this is let's see what case this is now. So sabi daw meron daw manufacturer of car batteries that claim that the life of the company's batteries is approximately normally distributed with a standard deviation equal to zero point 0.9. So if you were to get a random sample of 10 batteries which has a standard deviation of 1.2 years, uh, can we conclude na the sample mean is greater than zero point 0.9 years, which is the established na population standard, no, sorry, not sample mean, no, is the sample standard deviation greater than the established population standard deviation, which is in this case zero point 0.9 years, no? So let's use a level of significance. Okay, so this is a case wherein in this particular na ano, no, we are not comparing means anymore, we are comparing standard deviations, and that is in the realm of case 8 and case 9 na. So ito siya case 8 and case 9. So case 8 is let me find it here, no. Pagka case 8, we are comparing a single variance, no? So we are checking if a single variance, a sample variance, is comparable to a population variance. Tapos pag case 9 naman, we have multiple data sets, usually two. So we have two data sets or two variances. Tapos gusto natin i-compare kung ang two data sets ba na yun are comparable to each other, no? Okay? So, dito sa example na to, itong example number 5, gusto natin compare yung sample standard deviation, which is taken from 10 batteries, and it is observed to be 1.2 years. Gusto natin compare to sa population standard deviation, which is established to be 0.9 years. Okay, so let's do that. This is E5 case 8 siya. Okay, so let's do the hypothesis muna, no? So we have null hypothesis is that yung sigma natin, and let's get a sigma value, no? Sigma character para mas maganda. So sigma, let's small letter sigma, lowercase sigma. Let's do lowercase sigma. So sigma is equal to 0.81 or the sigma naught, no? So pwedeng i-state nyo this way or pwede rin sigma naught. Parang ganyan. So, let's state it this way, no? Sigma is equal to sigma naught, or pwede rin sigma, or wait, variance pala yung ano natin, no? Variance, so sigma squared. O kung gusto nyo mas maganda yung formatting, we can do a superscript natin to, no? Font superscript. Where is superscript? I forgot where the superscript is. Nandito lang yun eh. Huh? No. Hindi ko na mahanap. So, I'll just use a shortcut. Wala din. Sige, hindi ko mahanap yung ano, no. But maybe you guys know where to find it. So, gawin ko na lang is, I'll just use a hat symbol now to indicate na ano. Sigma. Ayan. Sigma, our variance, sample variance is equal to the population variance. Okay? Tapos yung next natin is, bakit siya automatic? Variance is greater than the, parang, let me just copy this na lang. Next naman is greater. Kasi ang sabi sa problem, sabi niya is, do you think that sigma is greater than 0.9? or etong 1.2 na to, is it statistically more, or is it significantly greater than this population standard deviation or population variance of zero point 0.9. Okay? No, sorry. These are standard deviations to, no? Normally distributed with, so I have to correct this, no? These are standard deviation. So, dapat ito, hindi siya squared, no? Dapat, tama lang pala yung kanina. These are not variances. Okay? Okay. Parang ganyan. Okay. Square root niya pala. Square niya yung 0.9. So, kasi these are comparisons of variances, no? So, kaya 0.9, okay. So, pwede natin i-retain. Sorry, class. Pwede natin i-retain na ganyan. Or stated in another way, parang ganyan. Lagay na lang natin 0.81, which is just yung 0.9 squared, no? Tapos, greater than 0.81. Right? So, we have 0.81, 0.81. Now, for case 8, we actually need to use the chi-square na, na value. Ito siya. And the chi-square is given as n minus 1 times the samples variance divided by the population variance. Okay? So, we have, let's set the alpha value muna. No? Alpha is equal to 0.05. 0.05 nga ba? Case 0.05. Okay, 0.05. So our alpha value is 0.05. Tapos let's get the chi-square value. So hindi ko nahanapin yung chi na value, no? Lagay ko na lang x. Sige, hanapin natin para mas accurate. Let's do chi-square, character. We use the lowercase chi. Parang hindi naman siya much different than just, sige, okay na yan. So this is the chi-square value, no? So chi, let's do, let me zoom in konti, no? So you do chi-square. The chi-square value is equal to, the formula is n minus 1, and let me, if you look at here, it's n minus 1 times the sample variance divided by the population variance. So we can go n minus 1, and ang sabi is 10 samples, Let me go back. 10 samples. Was it 10 samples? Yes, it's 10 batteries, no? So 10 minus 1, that's 9, multiplied by the sample variance was 1.2, I believe. Tama? Standard deviation is 1.2, so 1.2 squared power of 2 divided by 0.81, no? Or 0.9, or sige, gawin natin 0.9 squared. Okay? So this is our chi-square value right here. Okay? Alright. So same naman tayo na nakuha, no? 0.16. So this is the chi-square calc. Now let's get our chi-square crit. Chi-square crit is we do chi-square, and since ang hinahanap natin is a yung mismong chi-square niya along the x-axis, no? So we do inv. Okay? Chi-square inv. Tapos yung probability natin is 0.05, tama? So we can do 0.05. Ganyan. Degrees of freedom natin is 10 minus 1, which is 9. So we should get this value. So this chi-square int right here is, etong critical value na to is actually the left tail, no? So let's just say LT siya. Left tail to. If we want to get the right tail, then instead of 0.05, we should use 0.95. And since ano no, ang hinahanap naman ng problem is we do a right tail test kasi sabi dito greater dapat siya. So this is supposed to be a right tail, no? So since right tail tayo, dapat 0.95 gagamitin natin. So we have this chi-squared value of 16.91. One thing to note about the chi-square, no, iba yung distribution niya. It's not a normal distribution or it's not a symmetrical distribution. Ganito yung graph ng isang chi-square, no? Parang ganyan. And actually, medyo kakaiba yung mga ano din dito, yung parang tables niya. Kasi if you look at chi-square distribution, let's check ito. Chi-square distribution table. The chi-square distribution table, most di ba, most of the tables that we've encountered so far is from 0 to, from the left side siya nagme-measure, no? So it's from 0 to a particular value. Pero si chi-square distribution actually is opposite, no? From the right siya nagme-measure. So if you look at this is from the right. So infinity up to this point. Okay? Tapos if you look at this, nasa right tail din yung kinukuha niya. Okay? Tapos, if you look at others, ito, right tail pa rin. So, if you look at these tables, no, always chi-squared is measured from the right, no. You will rarely see a chi-square distribution na table na from the left siya nagbe-measure. And etong si, Excel, I'm not sure if ano yung ginagamit niya, kung right or left pa rin. Pero I believe right din tong si Excel, no. Okay? So, later ma-figure out siguro natin yan. So, this is important class, no? And another thing that you notice is si chi-square distribution, hindi siya negative infinity to positive infinity tapos zero sa gitna, no? Yung pinaka-left niya na point is actually the 0 point. Okay? So, ganito yung itsura niya. Tapos, it's skewed to the right, no? Itong tail, yung right tail actually na pull siya, kumbaga. Okay? So, eto, from 0 siya to positive infinity. Okay? Tapos, whatever value na makuha natin itong chi-squared, yung area under the curve niya is measured from the right. Right? So, yan yung parang main difference when we're doing chi-squared na distributions, no? We need to take this into account. Okay? So, let's finish up. Meron tayong chi-squared calc, chi-squared crit. Tapos, we can now make our conclusion, no? You can also do p-value as well, no? P-value. So, let's do p-value. We can do chi-square. This time, we do chi-square dist. And let's measure from the right, no? So, etong dist is from the left tail probability of the chi-square distribution. Okay. Si Excel pala, he has a, or it has a dist na from the left, tas meron din siyang distribution from the right. So, let's use .rt, no? We use .rt. Tapos, ang x value natin is etong critical value natin. Sorry. This critical value right here. Oh no, so calculated value, I should say. Calculated value, tapos degrees of freedom natin is 10 minus 1. Okay? So, we have 9 siya. Okay? So, that's 0.06. Okay? So, if you want to make our conclusion, we can do etong approach na to, hypothesis testing approach, pwede rin p-value approach. So, let's do both. Since chi-square, lagay ko na lang calculated is less than critical, therefore then we accept h naught. Tapos since p value is greater than alpha, then accept h naught. Tama, no? So again, magre-reject lang tayo ng h naught if our calculated is greater than the critical or yung absolute value, no? Pero in this case, since this is I also like to point out, sige, mamaya na lang siguro. So ito, puro positive value actually si chi-square distribution, wala siyang negative value. So pwedeng calc is less than crit siya. But there is also a case wherein you want to account for the left tail, no? Kasi ito nagkataon na sa right tail siya, so madali siyang ma-imagine. Pero if you have, for example, ito, no? Itong chi-square distribution na to, there is actually also a left tail dito. Tama? May left tail siya. Let's look at the left tail. Yung left tail actually, meron siyang left tail value dito and meron siyang right tail value. So, hindi na nag-a-apply yung kanina na sabi natin na ano, no? Merong absolute, pwedeng gawin lang natin is absolute value ng calc greater than absolute value ng crit. Tama? Kasi this time, kailangan nang i-take into account mo yung actual value. So, pwedeng ang gawin natin is, if you are in the right-tailed region, itong chi-square na to, di ba pag nagre-reject tayo pag nandito tayo sa mga critical regions natin, no? So, actually, may two conditions siya. So, pwedeng ang mangyari is, we have chi-squared calculated is either greater than the chi-squared critical of the right tail, or chi-squared calculated is less than the chi-squared value of the critical value of the left tail. So you have to check both, no? So it's an or condition. So kung pwede siyang pumasok ka sa left side or pwede rin pumasok ka sa right side. Okay? So in this case, right tail naman tayo. So okay na tayo dito, no? So ito na siya. Then we accept H naught since alpha by, so we can make our conclusions. And our conclusion would be, therefore, the chi-squared, what was the example? Forgot. Ano yun? We failed to reject H naught. So therefore, ang conclusion natin is that yung at 0.05 level of significance, we can say na yung ano natin, yung 0.9 is not significantly different. Yung 1.2, I should say, is not significantly different from 0.9. Okay? Parang weird itong ano, no, conclusion na to. Ito ay ano ko na lang, no, I'll just have to correct this. Tapos lagay ko na lang yung totoo dito sa ano. So, let me see, tapusin natin to. Since, therefore, the chi-square, therefore, the sample standard deviation is not significantly different than the deviation. Okay? So, yun. That is for example number 5, case 8. Then we proceed to example number 6 naman. Now, let's proceed with the last example, no, of the module. And if you look at this, saan ba to? This is example number 6. And this is under case 9 with two variances, no? Okay? So, the problem is, for example number 6, sabi daw in the example of case 2, which I believe is, ano ba itong example ng case 2? That was, I don't know, example 1, I think. Dito. So, in this example, we assumed, wait, ito ata, example 1. We assumed, where is the example in case 2? Ito ba? Wait lang ha. If a random sample, this is not it. Example 3 siguro. Ito pala. Example 3. Assume that the populations are approximately normal with equal variances. So, hindi case 2, no? This is case 5 actually. So, may mali dito. Edit ko na lang to, class, no? So, sabi dito, In the example of case 5, it is assumed that the unknown population variances of the two materials are equal. So let us justify this assumption. And in fact, sometimes though, class, when we do cases wherein we're comparing to two means, that is for the case of case 4, 5, and 6. Sometimes we need to lalo na pagka case 5 and 6, where 'di ba pagka case 4, it is known yung population standard deviation. Tapos dito sa case 5 and 6, unknown yung population standard deviation. Pero sa case 5 is assumed equal, case 6 is assumed na unequal sila. So in some cases, before you can proceed with determining if it's either case 4 or case 5, kailangan nyo muna i-determine through case 9 kung ano yung relationship ng variances nila. Okay? And this is exactly what we'll do here, no? Gusto natin i-prove or disprove kung equal nga ba yung variances ng two materials under case 5. So, dito, no? Case 2 kasi nakalagay dito. This should be case 5. So, case 5, tingnan natin, no? The data is this one given. Ito. Siguro, pwede kong i-copy na lang siguro to. Ganito. Okay? And let's go to our Excel. So, this is example number 6, case 9. And lagay ko lang para meron tayong basis. Okay? So, gusto natin i-prove na tama yung assumption natin dito, no? Na, tama nga ba? Ito nga ba yun? No, sorry. Mali yung kinopya ko. Case 5 is this one right here. No? Saan na ba yun? Case... Wait lang, class, nalilito na rin ako. This is not it. Eto, nandito. Normally with equal variances. So, let me just copy this, no? Para, ayan. Okay. So, ang assumption again is the populations are approximately normal with equal variances. Now, let's prove that they indeed have equal variances, no? Okay, so H naught natin is mu1 or the standard deviation or the variance. Let's just say var na lang mas madali. var1 is equal to var2. Tapos H1 natin is var1 is not equal to var2. Okay? So, dito, we can see, let's establish na si material 1 is the material which has 12 samples, as material 2 here is the one with 10 samples. Okay? So, same naman dito ang notation. No? N1 equals 12, N2 equals 10. Okay? Tapos, X bar 1 is 85, X bar 2 is 81. Right? So, now that we have this, we can actually use sana yung data analysis, because data analysis has an F-test. I believe F-test two sample variances, no? So you can actually compare the sample variances. However, it requires that it is a range, no? Similar to yung t-test na ginawa natin kanina na kailangan naka-range siya or data set yung binigay. Pero dito, hindi kasi data set yung binigay. Ang binigay lang is yung average na nung data set nung 10 samples, tapos yung pati yung standard deviation na. So we can't use this parang this quick method right here, itong si data analysis toolpack. So we'll have to do a manual method, no? Okay? So this is our H naught and H1, and let's establish an alpha. Anong sabi doon sa is it 0.05? Okay, 6. Assume, we use 0.1 level of significance. So, alpha natin dito, iba naman ng 0.1 tayo. Okay? So, meron na tayong level of significance. We now proceed to step 3, which is establishing of the critical region. Now, the F distribution is much like the ano no of the chi-square distribution na hindi rin siya normally distributed. So if you search F distribution, you can see na or hindi rin siya symmetrical, I should say, no. If you look at an F distribution, no, the F distribution is like the chi-square distribution, no, wherein naka-skewed to the right siya, no. Kumbaga yung right tail naka-pull pulled to the right siya. Okay? So you can see something that looks like this. And similar to the chi-square, most tables also have na yung shaded region niya or yung parang area under the curve is from positive infinity going to the left. So ito siya, measured siya na ganyan. Okay? So you can see it in most tables, no, parang ganito siya. So let's look at an example where we have a table. Let's type table. Kita natin parang ganyan. So similar sa chi-square, no, na ang distribution natin is um ang areas under the curve is measured from the right. Right? So although ang gagawin nating method again for today is ano no is using Excel ulit. Okay? So similar to the chi-squared method wherein and we can look at this now, the F. And actually meron pala tayong ano dito. So similar sa ginawa natin kanina na if we were to do a two-tailed test, pare ganyan. So this is let's say alpha over 2 to. Nandito rin yung isang alpha over 2. Then if you have something that looks like this, similar to chi-squared, naka-0 din yung sa left, no? Unlike dito sa mga t test natin, t distributions and z distributions, naka-negative infinity, positive infinity kasi to, tas 0 yung nasa gitna. Okay? So dito, 0 din siya hanggang sa isang f value, no? So this means that puro positive values yung nakukuha natin. Yung f value is a positive value, tapos yung areas under the curve is also positive. Therefore, we need to check two values. We need to check the f crit left-tailed tsaka f crit right-tailed. Okay? So kailangan din i-check yung both cases na to. So dapat for you to reject f crit for you to reject the null hypothesis, you need f calc should be less than the f crit. So less than siya dapat kasi gusto mo na pasok siya dito sa critical region na yun. So to the left of the left tail. Tapos gusto mo rin to the right of the right tail. So ibig sabihin f calc should be greater than uh, the f crit at the right. So this is an or, no? Okay? So yun yung similar to yung ginawa natin sa chi-square, no, na parang meron din tayong left and right, and I think I showed it earlier. Ito, no, sinabi ko na reject yung both cases na to. So dapat i-establish mo yung left tail and the right tail to know kung which, kasi since again hindi siya symmetrical tulad nung t distributions and z distributions, hindi tayo automatically pwedeng gumamit ng absolute value lang, no. So parang yung calc is greater than crit. Hindi tayo pwedeng gumamit ng ganito lang, no, absolute value, because puro positive to. Alright? So let's do that. And there are certain properties yung ano no, yung f tables natin. So or f values natin. So we can have something that looks like this. Ito. So actually pwede mong i-rearrange, no. So yung 1 over f alpha over 2 with the first one here is the numerator na we call this as the uh, numerator degrees of freedom. Minsan sa tables you can see this as DFN. Tapos itong second one is the denominator na degrees of freedom. So sometimes DFD nakalagay sa numerator, no. So ang ibig sabihin nito is pag binaliktad mo yung 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 degrees of freedom niya, so ginawa mong numerator and denominator, and you take 1 minus alpha over 2 instead of alpha over 2, then they are actually just equal, no, if you take the reciprocal. Okay, so meron siyang ganitong property, no. So this was back in the day, no, this was very significant because we only had one table, no? Parang isa lang kasi yung table na binibigay sa atin, and I'm not sure kung merong copy ng table. I can show you a copy of the table, pero usually kasi when we did this, we didn't have any access to Excel, no? So ang ginagawa is hinahanap natin sa table siya. Tapos para kasi yung table naman hindi siya as extensive as as we want it to be, no? Kasi sobrang daming values. So we had to do manipulation such as this. Pero right now, since we're using Excel, hindi na as important as before, no, yung relationship na to, pero I can probably show you that it still works, no, doon sa Excel. Pero in Excel mas madali na siya kasi merong functions for right tail, tas may functions din for left tail, so it's much easier to compute for the critical values critical values of the left side as well as the right side. Okay, so proceed tayo sa problem. Back to the problem. Let's first solve for the f calculated, no? So f calculated is fairly simple to calculate, no? Sabi dito, the f calculated is just the variance of data set 1 divided by the variance of data set 2. Okay? So kung binaliktad mo siya, kung ginawa mo data set 2 tapos data set 1 ang nasa baba, magbabaliktad din yung yung kumbaga degrees of freedom mo. So ang data set 2 mo ngayon siya magiging numerator, tapos data set 1 magiging denominator. So it's important kung ano yung in-establish mo na numerator and denominator, no, kasi it matters. Okay, so ang common notation is dapat lang when we set if we para hindi kayo malito, one thing you can do is instead of using S1 squared over S2 squared, pwede actually gawin mo Sn to indicate na numerator to squared over Sd squared. Pwede ganyan. Tapos ito, this is V n and this is Vd. Pwede ganyan, no? This is Nn Nd minus 1 minus 1. Just to signify na numerator ang 1 and denominator to. This is optional. Pwede rin naman just remember that 1 is always numerator, 2 is denominator. Okay? But again, it doesn't really matter as long as you remember. In fact, if you do, if for example, ang ginawa nyo is, pinagbaliktad nyo yung data sets nyo, ginawa yung numerator yung data set 2 and denominator yung data set 1, you will still arrive at the same conclusion so long as binaliktad nyo din yung mga degrees of freedom and yung doon sa f calculate yung sa pag calculate ng f values, binaliktad nyo rin tong mga values na to. Okay, so let's try to do this. So set natin dito fcalc is equal to var1 over var2. And si variance 1 natin is nakalagay, this is 4 daw. So that's 4 squared is 16 over 5 squared, which is 25. Okay, so we'll use material 1 as the numerator, material 2 as the denominator. Okay, so we have, this is our fcalc value. Compute tayo ng fcrit. And we'll have two, no? Fcrit values. We have the left-tailed value and the right-tailed value. Not sure if nilagay ko ba dito? Hindi ko na nilagay, no? We should have mas maganda para mas no? Accurate to. Mas maganda na isulat na rin natin yung left tail. Just to indicate na dalawa yung tinetest natin, no? So we have the left tail and the right tail, and this should be equal to, I can copy this, no? Chi-square inf 0.05 naman. Okay? So I have a left tailed and a right tailed. Although, sa bagay, kaya hindi ko siya nilagay kasi we already know na one-tail test to kasi based on sa problem, we know the directionality of the of the question, no? So parang hindi natin kailangan establish yung left tail para, so makes sense na hindi tayo naglagay ng left tail. So I'll just place right tail, no, just to just to remind you guys na we are taking the right tail critical value for this particular problem. Dito, it's a two-tailed test, no? Kasi gusto natin i-prove kung equal sila or not. We don't know, we are not assuming any directionality dito. Hindi natin sinasabi na si variance 1 is greater than variance 2 or hindi din natin sinasabi na variance 2 is greater than variance 1. So, kaya yung H1 natin dito is ganito, no? var1 is not equal to var2. And if we put this into words, this is the two variances are equal. The two variances are unequal. Okay? So yan yung H1 and H0 and H1, yeah. Okay, so let's compute. Since two-tailed test to, we need to compute for the critical values of the left tail and the right tail. So unahin mo natin yung left tail. So we go fdist dot rt. No, f dot dist lang. Say we're looking for the left tail. The first x value natin is yung, let me see. We have point. Oh, wait. No. We should be using f.inv, no? Sorry. F.inv. Tapos, since this is a two-tailed, ang gagawin natin is split natin yung alpha, no? And we have 0.1 kasi yung alpha dito. So, two-tailed test, the left tail should have 0.1 over 2 or alpha over 2. So, that's 0.05. Tapos, si right tail, meron din siyang sarili niyang 0.05. Okay? So, we have f.inf 0.05, degrees of freedom 1. Sabi natin si numerator itong degrees of freedom 1 while si degrees of freedom 2 is denominator. So dito, we set the data set 1, the material 1 as your numerator. Therefore, ang degrees of freedom niya is 12 minus 1. Tama? Kasi there are 12 samples. So, ang ang degrees of freedom is for F test, no, is always n minus 1. So we have 12 minus 1. So you can type 12 minus 1 or pwede rin diretso 11 na lang. Okay? Tapos, ang degrees of freedom 2 is 10 minus 1, which is just 9. No? Okay? So that's our left tail. Okay? Now, etong si right tail naman natin, this is equal to degrees of freedom 1 natin is, wait, let me check. No, we do fdist.rt kasi right tail to. And, oh no, sorry, finv. I always get it confused, no? finv.rt. And again, half of the alpha, 0.1 over 2, will be on the right side naman. Oh, sorry. So that's f 0.05 degrees of freedom 1 is still the numerator. Numerator in this case is 12 minus 1, so that's 11. Tapos denominator is 10 minus 1, which is 9. Okay? So this is the values, no? Same ba? Okay. Okay, so I mentioned na meron, kaya mo pa rin maano, no? Kumbaga, there is a relationship between the left tail values and the right tail values depending on how we look at the, I don't know, the equations. And pwede actually natin ma-convert sila kasi sabi natin, meron tayong relationship na established kanina, no? And let me just reiterate. Ito, sabi natin, yung 1 over f alpha over 2 with numerator 2 over numerator with the denominator being or the second data set being the numerator and the first data set being the denominator is just equal to this value right here. So pwede actually natin just to prove na this still holds true, pwede natin i-gawin siya dito, no? So if we do 1 over f in ng RT, tama? Kasi the 1 minus alpha over 2 is actually an RT na value. So we can do 0.05 degrees of freedom and babalik ta rin natin yung degrees of freedom, no? We do degrees of freedom 1 is now 9. Tapos ito will be 11. And we see that it's actually the same value lang, no? Okay? Tapos we can do the same dito. 1 over f in and this is for the left tail naman. Tama? Kasi kung baka babalik ta rin natin, this is for the right tail. So, dapat left tail naman to. Left tail, degrees of freedom 1 is, balik ta rin natin 9 and 11. And we can see, same lang yung values na nakuha natin. Okay? So, we can prove na we can if we were using kung kumbaga kung gumagamit tayo ng tables, dapat kaya natin ma-manipulate yung tables natin to get the values that we want, no? Pero kumbaga hindi na siya dapat necessary na gawin dito, no, kasi we have Excel to do it for us. Then right now hindi siya necessary na gawin to. Pero I'll just leave it here para to show you na you can compute it this way, no? All right. So, that's the F-crit value. So, pero just to make it complete, no, pwede rin na gawin natin is p-value approach, no? So, we can do equals f dot test, but I think this requires an array. Tama. This requires an array to get the p-value, so we can't use f dot test. Ang pwede natin gawin is f dot dist dot pwede tayong gumawa ng RT or pwede ring left tail, no? So since this is, if you look at the fcalc value, it's is less than 1, no? So meaning it's closer to the left tail than the right tail. Tama? Kasi if you look at this, parang ganyan. If your if your f value is less than 1, ibig sabihin nun, the the numerator is smaller than the denominator. So you're leaning towards the left tail, no? Dito. But if your value, your f value, or sorry, dapat dito ko nilagay siya. Doesn't really matter. Pero parang sinasabi ko is, if your left tail is, or if your f computed value or f calc is less than 1, ibig sabihin, si numerator is smaller than the denominator. So, it is leaning towards the left tail. Okay? So, mas appropriate na left yung kukunin natin if we want to get the if we want to do p-value approach. But if your f value is greater than 1, that means the numerator is greater than the denominator, and therefore it should be leaning towards the right tail. Okay? So, mas appropriate na yung right-tailed na p-value yung kukunin natin. Okay? Pero if you're unsure, you can always check both, no? Pwedeng kunin mo yung p-value from the left and p-value from the right. Then, check kung alin doon ang posibleng mag-0.05 or maging comparable sa alpha. So, ito, p-value approach, let's just use the left tail because we know it's 0.64, it's lower. So, we do f dot dist dot f dot dist, left tail to. And our x is this calculated value right here. Degrees of freedom natin is 11 and 9. Okay? And we do cumulative 1, meaning from 0, yung pinaka left portion, tapos up to this particular f calculated. Okay? And we get 0.2392. Okay? And I'm trying to check, no? Let me double check. Kasi kung p-value, should I multiply this by 2? Because it is from the left tail. Let me double check. Kung f this dot rt, let's do 11 and 9. It's 0.76 kasi parang measured siya from the left kasi, from the right eh. Should I double this? That is the question, no? I think I should multiply this by 2. Wait lang, class, ha? Let me double check the module. Kung dinouble check niya yung hindi na siya nag p-value approach dito, no? Okay. So, let's leave it at that na lang, no? Hindi na lang muna tayo mag p-value approach. I can double check this for you guys. Tapos, ano ko na lang, no? Or wait. Let me just pause the recording for a while, no? Okay, so, the p-value approach for a f test will always be will always be a one-tailed test. But since kumbaga, kung hinahanap natin yung p-value, it's always the p-value over 2. Kasi we are, think of it this way, no? If we have, for example, let me just draw it here, no? So, kunwari lang, meron tayong, ito yung distribution ng F test natin, no? And first is gusto natin malaman kung equal ba yung two variances, no? So we do, if we are not establishing kung alin yung greater than or less than the data set, then we do a two-tailed test, no? Kasi pwede siyang kumbaga pwedeng yung mag-reject ka due to your f value being over the right hand side na limit. Itong limit na to, pwede siyang lumagpas dyan, pumunta siya dito, reject h naught, or pwede rin na lumagpas siya dito, okay, sa reject h naught dito, okay, kung yung f value mo is less than 1, no? So pwede ganyan. Pero once you know, if you do a p-value approach, you will always lean towards one way or the other, no? So kunwari, if you do a p-value approach for this particular problem, it's your f value calculated is equal to 0.64. 64 nga ba yun? 0.64, okay? It's 0.64. Therefore, papunta ka talaga dito sa side. And therefore, you only do a one-sided test in a manner of speaking. One-sided test lang siya kasi itong 0.64 na to, you are trying to find 0.64 and gusto mo malaman kung ano yung area under the curve up to itong 0.64 na to. Okay? And we already know the left tail test is 0.034. Itong nandito is 0.34, no? Okay? So, if we were to do the p-value approach without knowing this 0.34, kailangan, since if we want it to be more sensitive, then pwede nating sadyain na, no, na, kumbaga, lahat ng 0.1, lagay natin dito sa left side. Gagawin natin siyang one-tail test. Or pwede rin, since we do not know anything about this, we can do 0.05. Pwede rin na ganyan. But, kumbaga, mag-yield siya ng different results, no? The more reasonable approach would be to make it as a one-tail test, no? Okay? So, in this case, regardless if we do a one-tail test or a two-tail test using the p-value approach, we will always get a greater than 2. So this p-value right here is only for the half tail, no? Kumbaga, if you can call it that, parang ganun. So this p-value right here is a one tail. So lagay ko na lang dito, one tail. This is a one tail p-value, or para mas maliit, space 1t na lang, is a one tail p-value. And if we compare it to the full alpha, which is 0.1, pwede naman. It still gives you the same results, no? Kumpara natin sa 0.05. The difference, magkakaroon lang siya ng difference if, for example, close to, kunwari, 0.7 yung lumabas dito. If you do the one-tail test, then magiging nasa critical region na siya. If you did a two-tail test, then nandun siya sa, kumbaga, kung two-tail test ginawa natin, ang mangyayari is pasok pa siya sa accept H naught region, no? So, yun, this is more complicated than it has to be, no? Itong si one-tail test. Actually, pwede pa lang ginawa natin is one-tail test to the left na lang, no? Because we already calculated F-calc. We know na leaning towards towards the left na siya, and kaya in this instance, mas maganda kung ginawa nating one-tail test siya, no? Nasa left tail lang tayo. In fact, siguro, maybe I can give this as a preview, no? When we proceed to ANOVA, which is actually based on F distributions lang din, we will soon find out, no, na F test will always be a one-tail test, no? Parang ganun. Pero yan, medyo looking further ahead na siya, no? So it has something to do with what we call as goodness of fit, no? Ang mga F test kasi Tawag natin sa kanila is goodness of fit. They are what we call as a goodness of fit test. And um, what we're trying to establish is if you do a goodness of fit test, usually this means that you are, I don't know, you are only dealing with one-tailed uh, tests. Okay? So, we can end with this na lang siguro muna na p-value. Tapos, one-tailed yung gagamitin natin. So, when we draw our conclusions, we can have dito since f calc is less than, I'm sorry, than f crit. Oh, no, sorry. F calc is greater than f crit left's tail, then accept H naught. So again, ang more accurate would be fail to reject H naught, pero for our case, okay na yun. Accepting H naught is parang understood na. Okay? So, or we can do if since p value is greater than the alpha, then we accept H naught. So therefore, conclusion natin, the variances, therefore, the variances are equal. Okay? So, justified yung ano natin, um, yung original na statement no, or assumption no, na we approximate na equal yung variances dito. And we have shown na equal nga sila na variance. Okay? So, probably, siguro kasi may mga ano dito, no, things that I should clean up. Before I'll send this file to you guys, pwede siguro i-clean up ko to konti para mas malinis siya tingnan, no? Okay? But you can also refer to the yung modules. Meron naman doon na parang kasama ding Excel file. You can also look at that. Tapos try nyo i-compare sa itong ginawa natin dito. Okay? So, yun lang muna. And I hope you didn't get confused, no? Lalo na kasi nag-introduce ako ng mga other alternative ways to compute. Tapos nag-introduce din ako ng mga more advanced concepts that should have been introduced sa ano pa no later na subjects, pero hopefully you got the lessons, you got a feel of your how to do this ano no itong hypothesis testing, and enough siya para matulungan kayo para ma-solve yung modular assessments natin. Okay? So, yun lang, and I'll see you next week na siguro class, no?